Imagine this kind of situation in an online shop. Hi, I'm Sandy. I wanted to buy an iPhone and some accessories. She puts the phone to the cart, comes to the checkout, and asks virtual cashier. How much do I pay for the delivery?
It will be $5.
Oh, that's cool. Then she takes a fast charger and a case for a phone and comes back with the same question. How much do I pay for the delivery?
It will be $15.
What? I'm pretty sure you could put it into a single parcel for just $5.
We can't do that for you because our script can't solve it. It works properly only for the products of the same kind. Otherwise, it just adds up other parcels.
Oh, I'm gonna do the shopping somewhere else. She kicks the cart and it lands on cashier's head. And she leaves. I mean, leaves, not leaves. Then we stop for a second and wonder, how could we prevent such situations from happening? We never know if products in the cart can fit into a single parcel, or what size it will be, or even how many parcels should we even use for bigger orders. So we take a sheet of paper and make some notes. Input. Products in the cart. Each product has length, width, height, and weight. Available parcels. Each of them has maximum weight, length, width, and weight, as well as some price. And all of that for multiple carriers so we can tell our customer what she can choose from. Output, delivery price. Solution, I am confusion. Don't worry, I'm here to help you. I went through that process myself, and after a few weeks of work, I can tell you that it's possible to solve. I'll show you how I did it step by step. And if you're wondering why my eyelids are red, well, that's because I wanted to look more like Patrick. It's not that I'm sick or something. Firstly, let's look at the simple example to make sure that you're following. Our customer has a single product in the cart, and its dimensions are 10 by 20 by 50 centimeters. Then if we look at our carrier's offer, it says that parcels no bigger than 20 by 25 by 40 cost $4, and parcels not bigger than 25 by 35 by 50 cost $5. And once again, we are trying to tell what will be the delivery price. So in that specific example, we ask ourselves, can we fit that product into parcel A? If we can't, let's try it for parcel B. And if that's the case, well, that will be the final price. And for a single product, it will always be a single parcel. Like, it doesn't make sense to split it in half. We'll consider this kind of cases for more products, but in the near future. So what do you think the delivery price will be for that situation? It turns out that the answer is $5, and that's because the highest dimension of the product in the cart is bigger than the highest dimension of the parcel of size A. So we can only fit it into parcel of size B. It will barely fit, but even if that's equal, that's fine, it still works. So yeah, the answer once again is $5. And at this point we could stop for a second and think, what could we do about it? Like, how the script should actually look like? Because yeah, sure, we compare the highest dimension, we could compare the lowest dimension or the middle. Like, what should we really do about it? But before I do that, let's first answer what is v3. And v3 stands for three-dimensional vector that is expressed as an array. And here is an example. It can be 2.5, -3, and 7. So pretty much three numbers. It can be negative, there can be floating points, and so on. And it might look optional because the input to the function could be x1, y1, z1, x2, y2, z2. But it turns out that it's better to store it as an array, and I will show you why in a second. But first I wanted you to give it a try. For example, if the numbers that we have given in that specific example, or you could try something different, but it will always be a single box and a single parcel. Okay, so this is how the script looks like. Now let's analyze what it's doing. So we can see that the first step is actually sorting dimensions. And now, do you have a clue why would that be? And just to make it clear, here's an example. If the box v3 in the input was 412, 4 could be length, width, height, it would end up being 124. And the same for the parcel size. And now what is important is that as we iterate over 0, 1, and 2, which stands for x, y, and z, pretty much, 3 dimensions, we can simply compare each of them, and if it's out of it, the box dimension is bigger than the parcel, we can clearly tell that in one of the dimensions, it's going out of the parcel. So it cannot really fit, and we can early say that it will not fit. We do not have to check all of the cases. If it holds for all cases, for 0, 1, and 2, we return true. I think it's the right time, so you can give it a try and try some random inputs and make sure that they are not sorted, so we can compare what does making the first step actually do. And you will see that if you do not sort it, well, you will fail, because in some cases it will give a wrong answer. Yeah, that's not so easy to find, but if you will try a few examples, maybe 4, you will see that, yeah, there is such case. I hope that's clear for you, and then we can go further. So let's look at the second example. Let's try 2 products. And I can tell you already, it's where the fun begins. At this point, it's not just the size that matters, but also the relative position of boxes or products in the parcel. Here is a visualization of what it might look like for a bigger amount of products. And what is important that each product we put in, well, could be in any position. It could be here, it could be there, it could be there, it could be on top, it could be there and here. Like, so many positions to choose from, and well, it's not the end of the story. We can also rotate this. Well, it will look odd, but you can probably see what I mean, that it can stand like vertically, and even now we could try to flip it. It will not look good by any means, but yeah, even the shadow is off. But you can see the point that, well, there is so many options to choose from. And at this point we can tell that it's no longer a math problem, but it's rather computer science. Oh, and by the way, I wanted to tell you that I did use sponges, and it might seem like a weird coincidence because, well, it was SpongeBob at the beginning of that video. But anyway, yeah, I used these to visualize what some scenarios might look like, because it's really tough to do it in like Inkscape or any graphic editor. So yeah, I use these. And this is part of a reason why I think it's so cool, like to solve this kind of problem, because it teaches you different ways of solving it. It's not just that you take a sheet of paper, but you have to think outside of the box, okay? Well, okay, it's not funny maybe, but yeah, there's probably many more other ways to try to solve it, or just help yourself. So yeah, feel free to be creative about it. Anyway, let's go back to the main question. As you can see, for a single product it was relatively simple. We didn't even have to visualize anything, it was just pure maths. And for 2 products, what it will look like is we take a single product, so let's delete that, let's put it to the bottom. And let's say that we have already put a single product into the box. Sure, it can be placed in many orientations, and here we can see that there are 3 positions that we probably would want to put another box in. And sure, it can also be in different orientations, so if you multiply it one by another, you can see that there is so many combinations to choose from, and we are just at the level of 2 products. And for more, well, it's getting crazy. And once again, why are we even doing this? So if you put one product on another and another, and if you take all of them, and you can tell that their positions, or like all the vectors that they consist of, vertices, corners, I should say, okay, corners, if they're all inside of the package, or parcel, I should say, okay, forgive me, if the parcel was that big, as I'm showing it right now, if they all fit inside of it, then we can tell that, yeah, the answer to the initial question is true. And it's important that it has to be just a single combination. We pretty much have to go through all of them to be able to tell that a single of them actually works. And it might be the case that just a single one works and all the others do not. At this point, it would be nice to think of any kind of simplification, like what could we try to solve first before we go to that question. It turns out that one of the best things you could possibly do at this point is to go to the second dimension, like we started in third. Yeah, we still want to solve it, but this will help us for sure, and it's way simpler. At first, it's so easy to visualize. As you can see, I can put it down here, and it's pretty clear what it means. I mean, this red area is pretty much saying, hey, I'm going outside of the box, so it's a fail. If I remove that box, which was here, it says, hey, that's fine, because we can all fit inside of here. And sure, this is just a single scenario of what the orientation of these boxes might look like inside of the parcel. And if you're interested, here's a task for you. Imagine that we have two V2 boxes, which stands for 2 dimensions, and their sizes are 1 and 3, 2 and 2 by 2, and 1 by 1. And then we have a parcel of 2 by 4. Feel free to say in the comments if in this scenario boxes will fit into the parcel, but what is more important is the code behind of it. So I would love to see some examples from you. And don't worry if that's too tricky for you, because I will explain all the details in the future videos. And I know we have just started and you might want to see the solution, but I decided to make it a series because there is so much to talk about. I should mention that this system is a part of my e-commerce platform. So in the future I might add some more features into it, so that would be additional video anyway. So don't forget to subscribe to this channel. Thank you for watching and see you in the next one. Bye!